Good morning, children. Welcome to your chemistry online class. From today onwards, we are starting a new chapter, that is solid state. So, from our childhood, we are hearing the word solid. What are solids? What are the peculiarity of solids? So, here you can see a picture of the arrangements of atoms or ions or molecules in a solid. By seeing this, what you are getting? From this, we'll get an idea that solids have definite mass, volume and shape. And the intermolecular distance, there will be distance between these two atoms or distance between two molecules. This distance is known as intermolecular distance. The intermolecular distance is very short and the intermolecular forces are strong. And their constituent particles, it may be atom, molecule or ion. They have fixed position and can only oscillate about their mean position. They cannot change its position, they can only oscillate, move or vibrate. And they are incompressible and rigid because the intermolecular distance is very less. Due to this, they are incompressible. We cannot compress it. If we take gases and liquids, we can compress it. We can compress it into smaller volume. But in the case of solids, we cannot compress it. So that is incompressible and rigid. These are the general characteristics of solids. And there are mainly two types of solids, that are amorphous and crystalline solids. What is amorphous solid? What is crystalline solid? So we can classify it as crystalline and amorphous on the basis of the nature of order present in the arrangement of their constituent particles. How the constituent particles are arranged in a solid, based on this we can classify them as crystalline and amorphous. A crystalline solid is usually consists a large number of small crystals, each of them having definite characteristic geometrical shape, and they have a regular pattern and their arrangements are repeats in each and every crystals. A periodicity we can see in crystalline solids. But in the case of amorphous solids, it is having an irregular shape. It is a shorter range order. A regular pattern we can see in a short distance only. It is a scattered like arrangement. But if we take crystalline solids, it has a definite arrangement. This is an example for crystalline solid you can see here. Here you can see there is an order, an arrangement. But in the case of this solid, there is no order, arrangement, etc. And if we take crystalline solids, they have sharp melting point, whereas amorphous solids doesn't have a correct melting point. It can, if we give some heat, it can mold into various shapes. On heating, they become crystalline at some temperature. For example, some glass objects from ancient civilization are found to become milky in appearance because of some crystallization. If we see some church window panes, etc., after some years it will change color. It is due to crystallization process. And amorphous solids have a tendency to flow. So based on this property, these are known as pseudo or supercooled liquids. For example, the window panes at the bottom, it will see thicker. It is due to the flow nature of glasses. Some glasses have this tendency. Thus, it will come under amorphous solid. Thus, it is known as pseudo supercooled liquids. And crystalline solids are anisotropic nature. That is, some of their physical properties like electrical resistance index show different values when measured along different digression in the same crystal. That is, if we take a crystalline solid, in this crystalline solid, its properties, we know it's having some physical properties, either melting point, boiling point, etc. Similar to that, other properties also there, such as electrical resistance, refractive index, such things in each direction. We know x-axis, y-axis and z-axis. In each direction, it will show different values, not isotropic. Isotropic means in every direction it will show same value, and isotropic means in each direction it will give different values. So crystalline solids are anisotropic in nature. It is due to different arrangement of particles in different direction. Here you can see there are different arrangements. Due to this anisotropic property exists. But if we take amorphous solids, on the other hand, they having isotropic in nature. It is because there is no long range order in them and arranged is irregular along all the directions. It is, there is a in crystalline solid there is a specific arrangement. Due to this, in each axis it is having different arrangement. Due to this, it is having anisotropic nature, whereas amorphous solids are isotropic in nature. So we can see a comparison between crystalline solids and amorphous solids. Shape. Crystalline solids having definite characteristic geometric shape, whereas amorphous solids having irregular shape. Melting point. Crystalline solids having high melting point, and whereas amorphous solids doesn't have a correct, gradually soften over a range of temperature. Cleavage property. When cut with a sharp edged tool, they split into two pieces and the newly generated surface are plain and smooth. But in the case of amorphous solids, if you cut it with a sharp tool, they cut into two pieces with irregular surface. Crystalline solids having a regular surface while cutting, amorphous solid having different irregular structure. Heat of fusion. They have a definite and characteristic heat of fusion. Amorphous solids doesn't have a correct or definite heat of fusion. Anisotropic nature, it is anisotropic in nature, whereas amorphous solids are isotropic in nature. They are true solids. Amorphous solids are pseudo solids or supercooled liquids. If we take the order, crystalline solids having long range order, amorphous solids having only short range order. And if we take crystalline solids, we can further classify it into 4 types based on the intermolecular force of attraction. We know there is an intermolecular attraction between atoms, ions, molecules. So based on this intermolecular attraction, we can further classify the crystalline solids into 4. Those are molecular, ionic and metallic, molecular, ionic, metallic and covalent solids. We'll see one by one. First one is molecular solids. These are further divided into non-polar molecular solids and polar molecular solids and hydrogen bonded molecular solids. What is non-polar molecular solids? These solids are soft and non-conductors of electricity. So there is no polarity. Polarity, we have seen polarity charged species, and they have low melting points and are usually in liquid or gaseous state at room temperature and pressure. They are held by weak London or van der Waals force. So if you take molecular solids, it is 2 type, polar and non-polar. Non-polar means they doesn't have any charge and they are soft, non-conductors of electricity, and they are held by weak London force or van der Waals force. We know there are different types of forces. In molecular non-polar molecular solids, van der Waals force exists. Then what will be polar? The opposite. That is the molecules of substance like HCl. That all we have seen that it is having a polarity, polar covalent bond, because the hydrogen and Cl is there. Chlorine is highly electronegative compared to hydrogen, so it will attract the electron pair towards itself. So hence it's having a polar covalent bond. So there is stronger dipole-dipole interaction between them. Even though these solids are soft and non-conductors of electricity, the melting point and higher than those of non-polar molecular solids. These are gases or liquids under room temperature and pressure. Example, sulfur dioxide. So molecular solids are classified into polar, polar and non-polar molecular solids. Then another type under molecular solids are hydrogen bonded. Because in the polar covalent bonds between hydrogen and fluorine, hydrogen or oxygen and nitrogen atom. In such cases, strong hydrogen bond we can see. H2O, solid like H2O, ice. In ice, if water is in ice case, there is a strong hydrogen bond between hydrogen and oxygen. And they are also non-conductors of electricity, and generally they are volatile liquids or soft solids under room temperature and pressure. So under molecular crystalline solids, three types: non-polar bonded molecule, polar bonded molecule, and hydrogen bonded molecular solids. Here you can see the image. If it is atomic solid case, ionic solid case, molecular solid case. Then we'll move to ionic solids. So ions are the constant particles. In molecular solids, molecules are the constant particles. Here ions are the constant particles. It is due to three-dimensional arrangement of cations and anions bound by strong electrostatic force of attraction. We know that these are ions. If it is an ion, there is electrostatic force of attraction between anion and cation. These are strong, hard and brittle. We know the properties of ionic compounds. They have high melting point and boiling point, because in order to break the electrostatic force of attraction, we need to give more energy. Since the ions are not free to move about, they are electrical insulators in the solid state. However, in the molten state or when dissolved in water, the ions become free to move about and they conduct electricity. For example, if you are taking NaCl, NaCl is non-conductor or insulator when it is solid state, but if it is in the liquid or molten state, it will conduct electricity. Such compounds are ionic solids. Here you can see the example NaCl, a cation and anion. There is an attraction force between them, that is electrostatic force of attraction. This is the representation, ionic representation of our NaCl. Next one is metallic salts. Metals are orderly collection of positive ions surrounded by and held together by sea of free electrons. We know about metals having free electrons. These free electrons are mobile, that is moving, which help to transfer electricity. Because of these free electrons, they are conducting electricity.